to ask questions first, or should we? Well, I
Why
think
don't
I
you
think
start with
Elizabeth.
your questions?
Yeah.
I think we'll want to introduce the speaker first, Elizabeth, and then we
All
can
right.
do.
So,
Yeah.
hello everyone. My name is Elizabeth, and I'm the director of development and engagement in SODA. And today, I'm excited to announce Richard Cohen, our guest, our speaker for today. Today's going to be an AMA, so if you guys have any questions, feel free to put them in the chat or just add them to the Google Forms. Our panelists are Ryan Wu, who's the Vice President of Operations for SODA, and Tinayu Preti, who's the Director of Technology. So thank you all for joining, and we'll be starting right now.
Hi, my name is Rich Cohen. I've been calling myself a software engineer for the last 40 years. For the last 30 years, my focus has been on collecting and organizing requirements for business information systems. And I've also had some interesting early experiences in the dark ages of computing. This thing is called Ask Me Anything, so go from there.
Perfect, thank you. Ryan and Tanae, would you like to start questions that you already have? And as
Uh,
people add questions to the chat, we'll address them.
Sure, that sounds good. So we're an organization of predominantly university students, undergraduate and graduate, um, primarily in computer science programs now, which I know from in your day those didn't exist not too long ago. And we have like the field has origins in electrical engineering, in discrete maths, like very formal math backgrounds and things like that. It's kind of had this union into what we call computer science. Now people calling themselves computer scientists. They're being programmed in this field all across the country. And I just wanted to kind of pick your brain about what you think, at least in your opinion, what the educational pipeline for people who want to go on and become software engineers is, and is computer science the path for all of them? If you're familiar with something called the software engineering body of knowledge, it's like this effort of trying to get this like this some sort of standard of what education do professional software engineers need to go through. It's kind of the same way they have that for electrical engineering, mechanical engineering, other traditional engineering fields. And yeah, just your thoughts on that.
Among other things, I'm a member of ACM, the Association for
Yes.
Computing Machinery, and they've published baseline curricula for computer science, software engineering, data science, a bunch of different areas. I'm not, I don't have expert knowledge of those. I've read them, I've looked at them, compared them, and I've got some thoughts about the distinctions between computer science and software engineering. Um, the term computer science came early in the game. When I was in graduate school, they were already offering programs. This is in the late 60s, early 70s in computer science. The term software engineering was invented in a NATO conference in, I think, the late 1960s, maybe mid 1960s, but I didn't see a lot of college offerings in that area. In fact, I was offered a degree path in computer science, and instead I chose to take a master's degree in system engineering, not if you will, because I thought that was closer to my own interest, which was requirements collection. Um, Computer science and software engineering are intermingled a great deal, particularly in the academic community, because most of these computer science courses or degree programs seem to be offered by computer science departments. Um, in principle, I'm not too comfortable with that. Um, to me, the nature of science is asking the question why. And computer science, its big focus from my point of view, is explaining why computers work the way they do, why logic works a certain way, why algorithms are more efficient than others. The focus of engineering is on creating things, building stuff. You need to know computer science to be a good software engineer, but that's not all you need to know. There's other things. So to me, the two are overlapping fields. The best analogy I can make is that software engineering is to computer science the same way electrical engineering is to physics. And while a good physicist could probably design a radio, you'd rather hire an electrical engineer to do that.
Mhm.
Does that help? And I'll be happy to answer follow-ups, but
Yeah. No, I think that I've heard that analogy before, and I very much agree with that. And like even talking about my own institution, Arizona State University, our computer science program has like specialized tracks in software engineering. But like, on the main campus, people who want to be on the main campus, that most of I think if you were to ask any average computer science student, 3 out of 4 would say that they plan to become software engineers or something like that. And something I've wondered is why don't they go take the software engineering program at the Polytechnic campus and things like that. And it very much does feel like sometimes there's some courses in the major that they're learning software engineering from in the same way that electrical engineering they take physics courses, but it was like if they were learning their electrical engineering concepts from a physicist rather than someone in the field. And I think maybe some aspect of it is that it's hard to source instructors who would want to stay in academia and are available to teach courses. Um, I guess that could be the same issue for electrical engineering as well.
and I think
Yeah.
a lot of this is due to the evolutionary nature of our field.
Uh-huh.
It's still growing, it's still spreading apart. For example, someday there'll probably be separate programs in data science that probably won't be part of computer science at all.
Yeah.
Um, Maybe in 20 years, we'll see software engineering inside the engineering school as opposed to some other place. Again,
Uh-huh.
it's evolutionary, and I can't tell you which way it's going to go, but my own if I had my druthers, I would treat software engineering as an engineering branch.
Uh-huh. Yeah. And the interesting thing about my institution is it is actually organized into the engineering school. So we don't share the school of math and the natural sciences, which is an interesting thing. But data science is with them. So there are these new programs popping up, and I wish they'd be more popular. It seems like everyone still ends up in CS. But yeah, interesting insights. Today, do you have anything to
Yeah, okay,
add to
so
that?
not exactly to add to that, but I wanted to ask because uh, you have been through like 40 years of computer science, like being in the field, right? Working with computers. How do you think like it affects us like culturally and like what effects have you noticed over time? Like, because like we're too young to see any major difference like since the first smartphones came on and now we are basically they're more powerful than the earliest calculators, right? So
I've seen okay, I've seen a couple of things that are interesting. I've been through one, two, three. I've been through 4 cycles of small computers. The first computer I learned to program had 40K of memory. And then the mainframes got bigger, and I was working on an IBM 360 that had an awesome 750K of memory, which back then was a great improvement. Um, then along came the mini computers, the PDP-8, and we were back to machines with 8K of memory. And they grew again, more and more memory. Then along came personal computers. My first Radio Shack had 48K of memory. Um, I bought a Macintosh with half a meg. Um, and then about 20 years ago, I worked on a project involving an embedded processor chip that had 4K of memory. What's interesting is that the tricks you learn to live with computers that have very limited memory, then you think that they're behind you, and then you discover you need to relearn the same tricks all over again. So I have seen this cycle of, oh, we got lots of memory, we don't have to worry about X, and then, oh, we have new kinds of hardware that put a premium on space, and those tricks are useful. One other thing I saw, I started out with mainframes, originally punch cards. But quite quickly, we went to dumb terminals. So you had a dumb terminal sitting on a mainframe. then along came personal computers, and you saw huge amounts of processing distributed to individual computers. And now what we're seeing seems to be a return client server, the web, the cloud-based computing back to the centralization. So we started centralized, we decentralized for a bunch of reasons. We're now centralizing again. Are you willing to bet we're going to stay centralized or find a good reason to decentralize again? I don't know, but I wouldn't be surprised to see a cycle there.
Yeah, that's something I've been thinking about, like, because uh, as much as I think I know about computers, there's always something that surprises me. That okay, like recently, like I learned that the calculators that we use today, they have better processor and memory than like the one of the first like computers, right? Like one of the like original huge computers. Like, but that's something that surprises me at times, at how like technology affects us throughout like generations and culture, like how it impacts culture as a whole.
Culture. Um, so I've been inside the computer too much to notice the culture game. But here's one thing I that strikes me as interesting. Until about the year 2000, all of our communications technology put a premium on the printed word. We typed, we wrote, we communicated text messages. If you wanted to deal in graphics or in audio, there were huge barriers. In the last 20 years, those barriers have almost disappeared. I suspect that the human culture is going to change, particularly the way we communicate. What we see with YouTube is an example. I mean, we didn't have things like anybody can post something, them live talking with whatever videos they want to put in it, as easily as you could write a 6-page paper on a subject 20 years ago, even easier. I suspect we're going to see some dramatic social changes. I think we've already seen some, but I think we're going to see a lot more because it is so much easier now to communicate with other than written words.
Uh, that would answer my question mostly. Yeah. Uh, Ryan, do you want to continue or maybe take some questions from the members?
Are there any from the audience at this moment regarding the topics we're on? Yeah, get the chat.
Well, if you guys haven't something immediately, I'll give you one of my favorite rants. I do requirements.
Yeah.
Uh, Basically, I help business people figure out what it is they really need
Uh-huh.
from a computer.
Yeah.
And one thing I've learned is that their initial sense of what they need isn't even close to what will solve their real problem.
Mhm.
In fact, a lot of my job is helping to peel the layers of problem down to the core.
Mhm.
Um, and it isn't easy. Um, you've all heard of the waterfall life cycle model,
I believe
which
most
is
of us are
which
familiar.
essentially says make sure you know all the requirements for a system before you start to design it. Make sure you have a solid design before you build it, then test it, and then release it. In principle, that's right. The highest risk in terms of failure of a project collapsing or having enormous cost overruns is mistakes in requirements.
Mhm.
So that's the pro argument. If you don't get your requirements right, you're going to be in deep trouble later. And there are lots of examples. The biggest cost overrun ever was the FAA's advanced automation system in the 90s and into year 2000, I think it was, I don't know, 3, 5, 7 trillion dollars. It was some, when they couldn't have been trillion, billion, I guess, but
Hmm.
huge amount of money. And Congress finally killed it. And when people went back and dug into what went wrong, they discovered that the requirements were continually rewritten to be more ambiguous rather than less in order to achieve political buy-in within the government agencies. Because when they had detailed requirements, different people objected. I don't like this. So the people writing the requirements watered them down and reworded them until everybody smiled and nodded. But they were smiling, nodding because everybody was interpreting the requirements differently. So when it finally came time to build the thing, they couldn't build it because they didn't really know what was required. Anyway, one area. But the idea of getting all the requirements down up front was not a bad idea when we were building an accounting system 40 years ago, because we already had accounting systems and all we had to do was describe what the current manual system did. These days, we're building systems that never existed for customers that never used them, trying to guess what it is that'll really make them happy. And you can't write all the requirements because nobody knows all the requirements. So this is the dilemma. What do you do? Along comes Agile, which is a wonderful idea, but it's got some flaws. And it basically says, if you can't get it all right, let's do a little bit that'll be useful and get a better understanding of the problem. And then we can do another little bit and get a better understanding. And we can keep accreting our understanding as we build pieces that deliver value, as opposed to having the customer wait 2 or 3 or 4 years before they get any return on their investment. They started getting a return within the first couple of weeks. This is a wonderful idea. This idea predates Agile. The problem that I see with Agile is there's a tendency to downplay the value of actually collecting all the requirements and organizing them. Oh, we don't need long monster documents. We'll learn it. Well, if you're dealing with a medium size or a small size project where 6 people can hold it all in their heads, yeah, that works. But what if you're dealing with something that's a lot bigger or complicated, like the maintenance management system for the entire US Army, which I've seen recently? That's pretty complicated. Um, you need to keep track of the requirements, and that means you need to use some of the techniques of the waterfall and somehow make the waterfall ideas and the Agile ideas work together.
Hmm. Anything, Tine? So I
Mm,
have a
no,
question.
not particularly. Yeah.
Okay. Yeah. So yeah, I've heard about this dilemma as well of like from user needs, like getting initial like requirements elicitation, and then trying to translate that into like functional, non-functional requirements, specifications. Uh, it being an issue, and then agile, what you everything you just went over. And like from my understanding, there have been like process models like Scrum, for example, try to take agile and try to fit it into like when you have larger scale businesses, making it so that they can still manage, because you still need to do some planning, they need to do budgeting, they need to assign people to work on the project for some amount of time, and then have risk analysis and things like that, tracking milestones. Uh, do you think, because it's been a very costly transition, I've read some articles on it of companies that wanted to adopt agile and spent years doing this, and they have what is it, like scrum like coaches and things like that, right? Do you think that the cost of the transition was was worth it in your experience?
I think, and the people who've influenced me for the last 40 years think that spending 2 years on requirements and nothing more was a mistake.
Hmm.
We needed something, but I can point to books written by, oh goodness, what was his name? Gilb. Gilb. Um, can't remember the first name now, but he was writing back again in the early 80s, the same notion that you need to do a small piece of good for the customer incrementally, so a form of
Hmm.
incremental development, if you will. And
Hmm.
what Agile is doing is basically the same set of ideas. Um, there are related problems. One of the notes I posted to your website a couple weeks ago had to do with the notion that what we do in software development is an unnatural act. Most human beings, and the more successful they are, learn to ignore detail. They learn to only focus on a small fraction of the detail, and the good ones develop an instinct for recognizing which details are the important ones and deliberately ignore everything else, or else they're going to be overwhelmed with too many details. President Jimmy Carter was an example of somebody who let himself get overwhelmed by detail. Um, we in software can't do that. We know that a single comma can cause a program to fail. There's not one detail in a piece of software that we can afford to ignore because it will be a bug, it will be a defect, and will cause the software to fail. So we've learned, and we're rather rare, to try to pay attention to every single detail. But the business people we deal with have been trained the exact opposite. And whenever we talk to the business people, we run into this, call it perspective clash. Um,
Hmm.
I want to get all the details from the business guy, and he's looking like at me like I'm crazy. Why should I care about all this? And if I ask him to review a 20-page list of functional requirements,
Hmm.
he's not going to do it. So that's another reason why Agile and user stories and things like that are useful because they allow us to give the business guy a small enough chunk of thinking that he will look at it and absorb it and talk about it, as opposed to giving him a big bunch that he'll just ignore. I call it the thud test. If I give you a piece of paper, one piece or two pieces of paper, we don't do much paper these days, and say, hey, this is what I've learned from you yesterday, you're probably going to pick it up and look at it. If I give you a bunch of paper stapled together that makes a noise when it hits your desk, it's probably going to go to the bottom of your inbox. And maybe if I'm lucky, a month later, you'll look at it. So again, it's funny. I'm a techie. I wanted to deal with technology, and I've discovered that the most important issues I've got are dealing with people and learning that if you're dealing with people, you've got to give them chunks that they can digest in a reasonably short period of time. And I'm still learning how to do that.
Hmm. So those process models of putting of user stories, things that they were willing to talk about. That's in your experience, that's made it easier for some client that the software's being developed for to like be willing to sign like someone to communicate with the product owner on a project or even serve themselves as the product owner. Um, in for example, maybe selecting what should be done in the next increment or having like
And,
feedback into that.
and just finding a person who's willing to play the role of product owner is harder now. Because the
Uh-huh.
people you want to talk to, whether they're senior executives or simply line workers, are usually the key people in the process whose
Mhm.
time is fully occupied. And you're
Yeah.
saying to them, hey, I want 4 hours a week of your time every week for the next 6 weeks. That's a chunk. And again, that's one of the dilemmas we're facing.
Hmm. Okay. It seems like some of the viewers want to move to another topic. There's always the elephant in the room, which is AI. That's popped up here with a couple of thumbs up. So I guess maybe we can move on to that.
I know
Okay.
nothing about AI.
But I think I can frame this question in a way that maybe you can have an educated guess or maybe an informed opinion on something. So I have something prepped here actually on the topic. So there are so many frameworks, libraries, toolkits, the programming language features, and like facilities within them today that were designed for humans to use to create like coherent source code, testable software, maintainable software, stuff that would reduce like cognitive complexity for human developers, but not necessarily for machines. In some cases, for machines, it's actually overhead. Um, and recently popping up, there have been a number of projects where generative AI, so code writing AI, which can take in natural language, produce workable code that in many cases it actually is able to be able to test itself like in somewhat realistic environments now. And like to give like a specific example, I forget the exact name of this project. It can read GitHub issues, right? So it's like some new feature that needs to be implemented, or more common, a bug that needs to be fixed, and it will generate some code, test it, and then it will create a pull request having solved that issue. And some of these models are getting to a point where it could maybe match like the productivity of a single developer, like in maintaining an existing piece of software. So it's not at the point where from just a set of user needs or something like that, it can create a piece of software, but it's beginning to be able to fix bugs and things like that autonomously. Um, and this kind of like brings in the possibility that maybe 10, 20 years down the road from now, it will be predominantly machines from requirements implementing code and testing it. And will all of our tools that we use in software, for example, name some here, stuff like all the major frameworks right now with like fancy things like dependency injection, aspect-oriented programming, so many object-oriented concepts and design patterns. Do you think those will become kind of like tools of the past if it is computers primarily writing this software rather than humans that need to primarily be understanding? They still need to be validating and still need to be testing it, um, but they're not building as much as they used to. And I'm thinking back to like I'm trying to I probably won't show this video, but I was looking at how like the pyramids were built before major like mechanized like machinery, right? And had all these ways of moving big rocks and rotating rocks and things like that that we have no use for anymore now because it's machines that do the heavy lifting or something. And yeah, I guess with that technology coming, what are your thoughts on it?
I'm a skeptic in one area. I'll
Mhm.
get to that in a moment. Um, the idea of some form of AI taking detailed requirements and turning them into code, I think that'll happen.
Mhm.
The problem is what we just talked about. Where do you get the detailed requirements? Um, if you've got human beings that are giving you ambiguous statements of business needs and practices, not just ambiguous, but skimpy statements, it's hard for me to believe that AI is going to fill in those gaps unless AI gets to the point where it can read minds. Um,
Mhm.
not only read minds, but read minds that themselves don't know what they want.
Mhm.
It's like, so again, the front end stuff of talking to humans and figuring out what they really need, I don't think that's going to go away. There may be less lifting in terms of generating executable code. Um, the other problem is testability. I mean, we talk. I hear these days they talk about AI. What do they call it?
A black
Giving
box?
no,
No.
giving incorrect answers, inventing
Oh, hallucinations.
hallucination.
Yes.
Well, what's to prevent AI software from hallucinating logic that isn't what's really required? And how do you discover that? Um, so there may be some risks in there, testability kinds of things.
Hmm.
Um, don't know. Um, certainly, now where AI may come in handy. This is a thought. A long time ago, have you guys heard of Tom DeMarco? Have you heard of Jordan DeMarco structured analysis? Yeah,
I
okay,
don't think
Dark
so.
Ages.
Yeah.
Um, DeMarco's a contemporary of mine. He's a couple of years older than I am, and he's still active. He invented one of the early techniques of system analysis called structured analysis. I had the opportunity to get to know him and work with him on a few occasions. And one day he gave a lecture to a client, and he commented, and this was when object-oriented programming was burgeoning, was becoming a major technique. And he said that he saw the problem with object-oriented programming, not so much a problem of programming as in finding the right pre-written objects in a library that contained 5,000 objects,
Hmm.
knowing which was the right one to use for a particular problem. He saw it as a problem of library science, that somebody
Hmm.
needed to come up with classification schemes and mechanisms to let people find the pieces they need. AI could be a partial solution to that problem.
Hmm.
That's the kind of thing AI, from what I've heard, when they're using it in cancer research, is
Hmm.
pretty good at, of saying, well, if you want to do X, have you looked at this article in this magazine, or in this case, have you looked at this particular object in this library? That might be a good fit for what you want to do. So there's an area where AI might be a real force multiplier, if you will.
Yeah. And I think in our experience, having looked for potential solutions for things, those are maybe in the audience or those of us who've been writing with AI assistance with codes, that's been what it doesn't necessarily always produce code that works, but for finding what you might need, or what might be useful, it's so much faster than however many Google searches that would be necessary for that, or posts on like some sort of question answer board or something like that. And yeah, I think that could be maybe to, and I think what this said more than anything, and when you're talking about still requirements remaining an issue, regardless if it's an AI writing the code or not, is that your career path should maybe be what some people are looking for in case they're worried about their job being automated away. So I guess take notes on that. Um, so, okay, I think we can do another question from the audience here. Yeah, yeah, stick with requirements engineering if you want to be automated. Okay, so a question from an audience member here. Did your career path follow what you expected? What advice do you have for navigating a software engineering career? So I guess the question is, did the career path you set down to follow, I guess, early in life, was that where you ended up however many years later in your career?
Hell no. And
Yeah.
I'm doing things now that I didn't know existed 20 years ago, let alone 50 years ago. I took electrical engineering. There was no computer science available in 1960 when I entered college. I took every computer course my college offered, my engineering school offered. 2 courses in FORTRAN, Introduction to FORTRAN and Advanced FORTRAN. 1 course in the design of digital circuits using vacuum tubes. That
Mhm.
was everything I could take in 60 through 65. At that point, and having worked at NASA as a co-op student, I was heading in the direction of being some kind of computer designer, a computer engineer, not necessarily a programmer. I
Mhm.
was an adept programmer, but I was looking at the lowest levels of hardware design. I was lucky at NASA that I got involved in early microcircuit research. Strictly as a junior grade technician, I was the dishwasher, if you will, although I did some
Mhm.
fancier things along the way. Um, if if I had if I had not entered the Army in 1965 because I took ROTC, I would probably have been an employee at NASA working in developing computers for space vehicles. And I probably would have enjoyed that. I entered the Army. And at first, because I had a background at NASA, they trained me in guided missile maintenance. I got to see a bunch of computers, for example, the Sergeant missile computer, which used rotary telephone selector switches for its logic. You put in the Mylar tape and you heard the switches click and clack, and they would program the missile to fire at the design target. Um, Mechanical, electromechanical, not digital, but not
Mhm.
electronic. Um, then, about halfway through my Army career, I suddenly got involved in a variety of business applications and also the educational application of computers by accident. By the time I left the Army after 10 years, I was oriented towards the business use of computers. Um, shortly after I left the Army, I learned COBOL, and I was responsible for developing business systems at Corning Glass. So suddenly I was doing software for business purposes, where 10 years earlier, I would have been doing software for aerospace, completely different field. Over about a 10-year period, I became deeply embedded in the structured community, structured programming, structured design, structured analysis. Tom DeMarco, Ed Jordan, I met them both. And that was more process oriented than anything else, although there was an aspect of logical database design, third normal form in what DeMarco did, but I was heavily process oriented. About 10 years later, I ended up as a part-time thing as a system operator on CompuServe for a firm devoted to software engineering. And we got really lucky that some of the leading lights of the software community used us as a sounding board for their own thinking. Ed Jordan wrote parts of his books and gave us early views and took our questions and rewrote what he was writing to reflect better insight. We were essentially his proofreaders, and others did the same. So we got to talk to these guys. One of them was a guy named Dave Hay. I don't know if you've read any of his books, but if you're interested in data modeling, he is one of the real leaders. Over about a 5-year period, he convinced me that data models were superior to process models for defining business requirements. And he convinced me of that, in spite of the fact that I'd spent 15 years as primarily a process model. Now I am more of a data modeler, much more of a data modeler than a process modeler. I wouldn't have expected that 20 years ago. So it's zigged and it's zagged. And if I were a lot younger, to be zigging some more, but I'm at the point now where I'm done zigging, I guess. So don't, you can't plan. This is an environment. Do what you find interesting. You got to constantly learn and be open to learning new things. And, expect to be doing stuff in 10 years that you don't know exists now.
Okay. Yeah, I think a good follow-up question to that from the audience right now was that over those decades of working in this field, still one of the fastest moving fields. What kind of like techniques did you use personally to like adapt to changes and needing to learn new technologies as they emerged, or whatever you were switching, what you projects you were working on?
Me personally, I read a lot. Remember,
Uh-huh.
most of that was before the internet became really available. So books were a much bigger deal. But even today, I think books are a tremendous source because they may be a little out of date, but they're much more thorough than the stuff you'll find online. So I think a balance makes sense. And let me throw out another one. Join a professional society, and I would suggest that you go to at least one major meeting every other year, if not one a year, either the IEEE Computer Society or ACM. Most of the meetings are held jointly by both of them. So it doesn't matter really which one you join. Doesn't hurt to join them both, but it's going to cost you a little more. Um, and get involved. Those are the places where you'll get what's the right word? The most thorough and up to date new information. Both the live conferences will be presenting people who are doing stuff right now, and the magazine publications will be a lot more timely than what you'll find in form of books, and will be more trustworthy than you'll find in most places on the internet. I really believe that professional societies are a valuable component of professional development, and I strongly recommend it. I also recommend reading, and not reading alone. One of the things that I fell in love with was study groups. 3 or 4 of us would read a book together over 3 or 4 months. And the rule was you'd read a chapter and everybody would have to say at least something. It could be bad. It could be, this thing is awful. I can't see how it would be relevant. Or, I did this and it worked, but here's a problem. Or, I've never tried it, but it sounds like a great idea. But we would chew it over. We wouldn't just accept the book. I've never read a book that I didn't object to something in it. Um, so the act of 3 or 4 of us mutually chewing over the ideas would help, you know, make them personal, put them into our heads in a much better way. And you can do that on your own. You pick a good book and you spend some time doing it over lunch once a week. Now, there are lots of ways you could do it, on this website. Set up a discussion area, and here's the book we're going to talk about, that kind of thing.
Okay. Maybe that answered their username is user. That answered their question. So maybe some techniques to consider. And I guess in our community we have somewhere we could discuss. Do we have a channel for?
I think we
I've
have,
never
but
actually
it's not really active. Yeah.
our community first. Maybe we could revitalize that, get some conversation starters. Yeah. But we have another question from the audience now. This one's from Isaiah. So he's worded this as: is there a place for computer scientists to get interested in more people interested in computing? To also want to be more hands-on the physical side of the engineering process. So I guess it's saying as opposed to professional organizations like ACM or IEEE, somewhere where they're working on. Maybe Isaiah could clarify the question if I'm not getting it right. The hands on the physical side. To me, that sounds like hackathons. But hands on. Okay. I would say hackathons. I don't know if um, uh, Mr. Cohen would have any other recommendations.
Again, I'll go back to my notion of what's science.
Yeah.
Science is coming up with a hypothesis, testing it, trying to disprove it, trying to come up with more precise explanations of how things happen. Ad hoc kinds of things, heuristics and that sort of thing, that's more inside engineering than it is inside science. It may be taught in a computer science curricula, but I would say that that's not science. Not that it isn't important. Um, Hackathons. I've never been in one. I've just heard about them a little bit. One of my small peeves, and this dates back maybe 20 years because I haven't worked with coders in the last 20 years. I've been working at the enterprise level. And although I've looked at design material, I haven't read anyone else's code for at least 20 years. But when I did, there were some programmers who had really bad habits. And it looked like they developed the bad habits early in their life with nobody to point out to them what the problems were. Um, they they were working with a group of peers, none of whom had any sense of good practice. My big area is maintainability, and I've learned that the hard way by trying to maintain code I wrote 20 years ago. A lot of programmers, again, don't know any better and were in environments that didn't teach them. Now, I would expect that these days modern computer science programs is teaching a lot more discipline and explaining why certain things are worth doing that didn't happen much longer ago. But it's something that I did notice back then, and I'm concerned about. It's essentially it's the computer version of ghetto English.
Mm. Yeah, and I will say as someone who has graded a large number of programming assignments in my experience working for the university that there's an effort to try to teach better habits, but it's still well, I guess you see the worst of it when you see it from people who are learning. But I think it takes so much effort. At least I'm talking more as like from an educator kind of standpoint to give that feedback to students on a regular basis, especially when you have courses that have hundreds of students in them now. Now we're scaling up to like thousands. They have these mega courses where they merge them, it's like flipped classroom, food corner. That's a tangent, but like it's you would hope that from these educational institutions, from their computer science programs and the curricula, they would teach them to write good code, but it I feel like it's being neglected to some extent. And sometimes there's content where they're more interested in giving you, I guess, the breadth of things. Like they want to give you a bit of OS, of systems, of automata theory, um, and it kind of it seems like they're teaching more about the interests of someone who's going into that background of like figuring out maybe some things at very theoretical level, how you could improve computing rather than the practical of
Mhm.
writing good maintainable code.
And that's the
Yeah.
distinction between science and engineering. Computer
Yes.
science, the things you described are legitimately part of it.
Yes.
Writing maintainable code, writing efficient code is more engineering than it is science.
Yes.
And I can imagine the student that you're grading saying things like, but my code runs, it produces
Yes.
the correct answer.
Exactly.
How can
Yes.
you downgrade the code?
Hmm.
Um, and that's one of our problems. Incidentally, if you guys don't have a copy, the Elements of Programming Style, which I think dates to the 70s, Kernighan and Pluger, um, is a wonderful book for beginning programmers. It explains a whole lot of things about writing good code. Do you still have the situation of the programmer who tries to show that he can package the entire solution as a single line of C or
Yes.
some other language?
Yes. They call them clever coders, or it's a derogatory term actually, where
Mhm.
they're like their beautiful one-liner, and someone else comes along and try to read it. It ends up being harder to understand, and there is even this misconception that like a lot of first-year students have that less lines of code is better.
Yeah.
That yes, that's still very much a thing. It's an age-old problem that some of them don't believe you until they learn more about how stuff actually gets processed and things like that. They think they translate how performant code is of how short and compact the source code looks, which couldn't be further from the truth, right? So that's yeah,
I remember in my C days, people used
uh-huh.
to have contests for how could you write the same thing in the fewest number of lines of code.
Hmm.
And again, that's a great mental exercise, but it doesn't produce useful business results.
Hmm. Okay.
If I may, Ryan, I'd like to hop in with a question.
Yes, I noticed you asked to speak. So just to introduce Nick here, he was our former director of ministry relations. He's now the vice president of finance. So usually more on the internal operations side of things. So I guess he's joining us today.
Yeah, it's fantastic to meet you, Richard Cohen. It's
Mhm.
been an interesting conversation thus far. And as someone who's currently in the midst of my internship, acquiring wisdom from all kinds of sources, learning, thinking, deciding, a lot of decisions in life, they alter your life. And one of the topics that I've been hearing about is this idea of, I see somebody broach this topic in the chat, specialization. A lot of the wisdom I keep hearing around here is get good at something. Get really good at something. Get so good at it that no one else is as good as you, and you're going to be okay.
Until
And
what you're good at goes away. Um, when I went to graduate school as a system engineer, the professor, the head of the department in the first course, in the first day of the core course in system engineering, said a system engineer should be a T shaped man. You should have real depth in some one technology, and you should have breadth across a whole range of technologies because you need to talk to people with other technologies in order to build a real system. Um, at one point, I wondered fasciously if you should be a pie-shaped man with depth in two areas as opposed to just one. Um, but the issue is, and part of the issue was, if you know just one thing, you're going to have a hard time communicating. So you do need depth. One of the truths of getting a job in almost any area is they are hiring for depth in a narrow area. Read most job wanted ads, and they have a specific idea of what they're looking for. If you haven't got 5 years of experience with no SQL and R, they don't want you. If you, that one depth is what they want. So to get the job, you need some real depth in some one currently active area. But to do real good once you've got the job, you need a lot of breadth because you're going to be dealing with requirements. One of the awful truths of my awful truths is I was a typical engineer. I hated English. When I graduated college, I couldn't write. I could not write coherently in English. It took me 20 years to learn how, and it took me about 20 years to learn that it was really important to know how. Well, that's just one example. You need more than just technical depth. And whatever you have technical depth on today, that depth is going to be, what's the half-life of knowledge right now in the computer field? Is it 5 years?
Let's
You know,
say that's pretty close to that.
so whatever depth you've got now, unless you keep redigging that hole, it's going to go away. And even if you dig the hole, it may turn out that it's a dry hole. You got to you got to plan to keep learning, and it's probably prudent to learn something different as well as whatever area your depth is in, so you have a fallback. Again, look around. How many technologies, how many programming languages were hot 5 years ago, and now nobody cares? And that's just one example. So you got to mix breadth and depth, both.
But would you say that depth of some kind is still necessary, right? As opposed to someone who might have the mindset of, oh, I need to be a jack of all trades, master of none.
Well, I'm a generalist in requirements, and that's a hard time every time I go looking for a new position. What do you know about aviation, or what do you know about healthcare, or what do you know? And often my answer is very little, but I learn fast, and that's not a winning answer. So yes, you need depth, and you need depth in something where people are hiring. But again, that's what's going to get you in the door, and you got to have enough to get in the door. But realize that's not enough to help you be really productive. You need more than what gets you the initial job interview.
I see. I like that T-shaped man. That's a neat concept.
Oh,
Thank you.
you're welcome. It wasn't mine. It was my professor in grad school.
Fair enough.
Okay.
And let me mention one more thing about getting a job. A lot of people are desperate to get a job, and they constantly try and sell themselves. You're also out there to determine if you're going to be happy once you get the job. You're interviewing them as well as them interviewing you. And the most significant element in the quality of a job, in my experience, is the person you're going to be working for directly. I've had some terrible bosses that made life awful, and I've had some wonderful bosses, and not necessarily experts in the computer field, that made life a pleasure. You want to know who you're going to work for, and before you take the final offer. Um, it's really nice to know who you're going to be working with. Now, with some large companies, you may not be able to do that because they may not even know who they're going to assign you to. But the nature of your immediate supervisor is going to be the make and break for how happy you are. And it doesn't matter the reputation of the company, it's that individual you work for. And if you discover that that's not the right person for you, then either internally or by finding a new job somewhere else, you need to do something about it. Your immediate boss is key to happiness and success.
Richard, do you have examples of you doing this? You reaching out to your boss before
I
I have
have
heard of this before, actually.
examples of insisting that I interview with the person I would be working for. And there was one case where I declined an offer as a result of that. Now, I've been a consultant. I've not, 90% of my, since 1985, was as a self-employed consultant who did 6-month to 12-month gigs, initially in the design of systems, and then more recently in requirements gathering. And I had experiences of bosses that made life difficult, and I had experiences of bosses that were a pleasure to work with, that were force multipliers for me. Particularly, the best boss I ever had didn't know a lot about computers, but he knew the politics of his organization. And he would pre-brief me on any time we'd have a big meeting. And he'd stop me when I was saying something. He'd say, "You know what you just said? Joe is going to think this." And I'd look, "That's not what I meant." He said, "I know that's not what you mean, but you can't say it that way. You've got to say it so that you communicate to Joe." And we would practice changing the wording. Essentially, he helped me avoid the political minefield of the organization because he knew what that was. And it made me so much more productive and so much happier. I'm not a good politician either, so that was another reason. But um, again, a good boss makes life a lot easier.
Interesting. So some companies have granted your request to let you meet the boss before you take the job.
Yeah, well, some places, I mean, you actually interview with the person who will hire you, who you'll be working for. A lot of times they bring that person into the room and they're there. But there are times when that doesn't happen. I've seen both. It depends how big and bureaucratic the organization is. When I went to work for a large consulting company, I didn't talk to anyone. I talked to people that were 2 levels above the person who would be my boss. And they liked me, and I had a graduate degree. Again, big consulting companies love to see lots of academic credentials because they can put that on their proposals for clients, impress the clients with your resume, and they hire people on that basis a lot. So I interviewed with senior people who saw that I was intelligent and knew they could use me, and they were right. And I ended up working for a pretty good boss, but I didn't know that until after I'd been hired.
Hmm. Okay. Oh, thanks.
Yeah, and I think I don't know what other people's experiences have been, but I know of a lot of junior software engineering position. I think some of the last phases of the interview process are sometimes with people from the team that you will eventually be joining. At least I've heard some of that.
Let me
So I guess,
recommend the book.
yeah. Oh,
Beware. Tom DeMarco and Tim Lister. Where is it?
yeah,
Oh my
Yeah,
goodness.
there it
Look
is.
at that archive.
yeah.
What?
This is the structured programming
No, no, no,
software.
no.
Oh,
This is about the human aspect of the software development business. In fact, they
oh,
have a chapter there of how they used to interview employees. And one of the lines at the end was, a candidate was rejected because somebody said, but he wouldn't like pistachio ice cream. And what that really meant was he wouldn't get along with that particular group, all of whom liked pistachio ice cream. But they were looking at personality. They were, not just hiring technical skills, but they were looking to hire people that fit the org. And the message is that you really want to be in a group where you fit from a perspective of outlook and attitudes on things. And whether you like pistachio ice cream isn't so much the important thing. Is again that you're going to end up in a team that's going to work well together. This is an excellent book. The authors, DeMarco and Lister, feel that it cost them a few $1 million in consulting engagements because it a lot of large bureaucratic companies thought it was revolutionary. And I got to say that Tom DeMarco is a bit of a revolutionary, um, but he's a very smart revolutionary with wonderful insights in the industry.
and I'm pulling up that book now in case anyone wants it. Mark.
Richard, how do you keep organized with all those books? I actually thought that they were, intellectual socialite props. But the way
Oh
you
no,
went and
no,
picked
that's a
out
work
that book,
library.
the way you went and picked out that book, like you had a Dewey Decimal System in your brain, that's fascinating. How many?
The things, but that's a book I pull every once in a while to look at. It's basically the most general software engineering stuff is in the upper right, and then it works down through project management, analysis, design, um, database, user interface, testing is in there somewhere. Programming is down on the lower corner. I don't have a lot of programming related books. There are about 300 books there.
Irony.
Read
Yeah.
maybe 80% of them cover to cover, and the others are read bits and pieces of. Most of them are good. Some of them are trash. I haven't thrown them out because occasionally even the trash is worth looking at. That's You've heard of Sturgeon's law. 80% of everything is worthless, which isn't what he actually said, but it's close enough. So you find the gold nuggets. You find the ones that are really worth reading. Anything Tom DeMarco wrote, anything Jerry Weinberg wrote. Who are my other favorites? Dave Hay. Again, I got to know some of these people, and you know, and I'm not sure if I got to know them and respect them because of what they wrote, or I read what they wrote after I got to know them. It's a bit of both. But like I've got probably 15 books by Jerry Weinberg. His first books was The Psychology of Computer Programming. Um, anyway, if you ever want to do this again, I'd be happy to.
Maybe in the come fall when we're having some larger events, we might have you come back on as
Yeah.
a speaker. I think it's something we'd
Yeah.
be interested in. But
And
I
if you
think
ever want to do a study group on something,
uh-huh.
if it's a book that I'm familiar with, I'd be happy to participate.
Okay. Yeah, that's an idea. But I think we're nearing being out of time now. Yeah, so Elizabeth, do you want to close off the session at this point? We'll take any of our like last questions now, but looks like we're good.
I think we were able to get through most of the questions in the chat. So thank you everyone for asking questions, and thank you, Mr. Richard, for answering off them. Great answers. I learned a lot. I was just taking down notes during this entire session. So thank you again, everyone, for coming. If y'all have any last questions, feel free to just keep adding them even after the session closes. But thank you again for coming. And Ryan, Tanae, do you have any last closing remarks you'd like to add?
One more thing. I'm monitoring this website, and if anyone simply posts a question to me, I'll be happy to try it. For the last month, I've been out of work, and I may never have another paid job. I like to talk about this profession, and this may be an opportunity for me to enjoy myself. So, if you want to post a question to this website, there's a good chance I'll answer it.
You
Yeah.
maybe should even look into creating a Calendly to let people schedule time to talk to you one on one.
I'd be
Uh,
delighted.
okay.
I mean,
Yeah.
literally, I sit here. This is the basement of my home. For the last 13 years, this has also been my office.
hmm
As a self-employed consultant, I was working remotely long before COVID came along. Um, so here I am. And my wife has a long list of things for me to do. So it's not like I have nothing to do.
hmm
But
Right.
um, but I'd like to keep my mind in the game of my profession, and this may be an opportunity for me to enjoy myself. So yes, if you want to set something like that up, I'd be happy to see what happens.
Yeah, I think maybe we can even create an expanded partnership with Soda here. I think you have been a fantastic orator, and
Okay.
I'd be happy to have you back again.
I would like to ask something that's probably gonna have some debates around after this conversation ends. Uh, in an ideal situation, what operating system do you prefer? Like, would you go more towards like Linux or Windows or Mac OS, something around that?
Well, I'm a Mac bigot. I've been using Macs since 1985, and the only reason I didn't buy one in '84 was that the memory was too small. I lived with the VAX for quite a while and learned to hate overlaid memory, paged memory. When the IBM PC came out with the original 8086 chip, and I saw that it was a paged memory architecture, I said, never will I buy a computer that uses that architecture again. And I discovered the Motorola before the Mac came out and said, hey, that's a computer with an architecture I really like. And then the Mac came out with the 8086, not the 80, with the 68,000 chip. And it was both, a modern user interface for the very first time. I was also disgusted with command line interfaces. Again, I'd lived with a lot of computers with command line interfaces. So I'm a Mac bigot. Probably I'm making a mistake continuing to buy Macs, but that's what I'm talking to you on now. And I was a Mac developer for a while, but that's another story. So, and I'm happy to talk about that kind of technology. I have limited understanding of Windows. I try to avoid it as much as I can, but I'm somewhat knowledgeable in the differences. So.
You have to be to talk smack, right?
Yeah, well, you can insult the other guy without knowing his true character. We see politicians doing that all the time.
Yeah, but it doesn't cut as deep, you know.
Yeah. One point in our distant history, one of the organizations that predated SOTA was a group called the Windows Users Group.
That's
No,
funny.
Windows Interest Group. Windows Interest Group is what it
Oh,
was. Yeah, it predates even me. Like I heard that as like I think our earliest roots back in like when we were when we were 5-year-olds. That's what SOTA was back then, or something like that. But that's what I heard.
Regarding
Anyways,
regarding Windows, the year after the IBM PC came out, I saw want ads. You were asking about depth. I saw want ads asking for people with 2 years experience with MS-DOS. And this was less than a year after the IBM PC came out. This is typical of what hiring companies are looking for. We want depth, even if it's an impossible amount of depth in some particular area.
I've heard stories of that. Still happens. And some of it comes with HR people putting the listings on sites, not being they don't know. Some listings you see there, some a little nonsensical, but yeah, that's just some things are timeless. It seems.
and how did you react? What did you do with that listing?
A bunch of us laughed when we saw it. I mean, I was in an environment where I can't remember where I was. I could work it out, but I think we were using Apples for some purpose. These were Apple IIs at that point. But it was pretty obvious that the hiring manager or the hiring people, not necessarily managers, we're told we want an expert in MS-DOS so we can start doing stuff. And then they just took the word expert and replaced it with 2 years of experience. So the techies, and that's what I was. We all laughed. Clearly, those business people don't know what they're talking about. Nothing unusual.
Mm-hmm. Okay,
I think that's
I
a
think
wrap
we're
on our
ready.
conversation for today.
I think we're ready to wrap up the session for now. But thank you so much for taking the time to speak with us today, Mr. Cohen. Your thoughts on things. Seems a lot of the viewers here enjoyed it. There's something going on here in the chat regarding the OS debate. But yeah,
Thank you for inviting me. I've certainly
mhm.
enjoyed it.
Okay,
And have a great weekend.
yeah.
You too. Thank
You
you.
too. Thank you.
All
Bye.
right. Bye. Have a
Have a
great
good
time.